Hi, welcome to the next session of an Intro to Data Analysis. In this session, we'll be focused on exploratory data analysis. And by the end of this lesson, you should be able to explore data via the question, query, learn loop, and that's exploratory data analysis, essentially. So if you recall, we started out this process with data visualization. We moved into transformation. We learned how to select, filter, arrange, mutate, summarize, all with group by. And from there, we went back into visualization. We applied some of those skills, went a little deeper with theory of visualization, and learned a bit more about ggplot too. Now we're going to put all this together, and we're going to use it to explore data in a process called exploratory data analysis. We'll be using the ggplot2 package and dplyr primarily for this. And just to recall what we've learned so far, some important elements for data transformation, we have the 5 verbs plus group by. So select grabs columns by name, filter grabs rows that match a condition, arrange reorders the rows, mutate adds a new column or overwrites an old one, summarize reduces variables to values, and group by can work with the latter 4 verbs to operate by splitting apart the data, applying a function over it, and then recombining the data back together. Also recall that we're looking for particular relationships. We're interested in relationships between variables, and this is the graph selection matrix from View. Along the left are those types of relationships we're looking for, and then the types of geomes that can be used to show those are across the top. This is similar to the New York Times, except for the New York Times tool actually gives us plot types that we can use, so whatever you're more comfortable with there. But the real point is these are the types of relationships we're looking for, and these are the ways that we can show those relationships. Also, the types of patterns we're looking for, Stephen Few shows us these are the types of things that are interesting. So when we're looking at the relationships, this is the aspects of those relationships we're looking for. Things like gaps and clusters, or things that are outliers or abnormal, or we're comparing what's high versus low, what's going up steeply or gradually, those sorts of things. And just guard against finding things that you want to find and excluding things that don't necessarily fit your theory. So this is called the Texas sharpshooter fallacy, where we find something interesting, we paint a target around it and say, yeah, that's what I'm heading for. So look for things that run counter to what you're finding. Don't just commit confirmatory bias, where you want to find something and you go find it, or you find something interesting and you ignore things that run counter to that. So look for things that counteract what you think is happening, the patterns you think are happening in the data. If you can't find them, that's stronger evidence that indeed you have some sort of trend or pattern that's interesting. Now, what all these techniques allow us to do exploratory data analysis. So what is this exploratory data analysis? It's a fairly simple but really powerful technique. It's 3 steps. Basically, you start with some sort of question. It can be a poorer question. It can be like more qualitative in nature, like how might I, or what is, something that's not well fleshed out, right? And then second step is you go to the data and you get those answers either by transforming the data and or visualizing the data. And along the way, something will happen. You'll notice, and this is where the 3rd step comes in. You'll get to the end of that, and you're probably going to ask new questions, or along the way, you'll ask questions, and there'll be better questions or different questions. So you refine those new questions, and you start the process back over again. And this is an iterative process, and you keep doing it until you've explored and you've understand your data set. So to do this, I think one of the best ways is for me to model it, then for you to do it on your own, and finally for you to do it completely on your own, and then demo what you've learned. So let's start off by loading the required packages here, and you'll notice one new one is lubridate, and this is really useful for working with dates in R. And the other package is tidyverse and example data we've been using. After that, it asks us to use View on the traffic violations data set. So go ahead and do that now. You'll notice that it took a little bit of time to load this into View. This is an actual real data set. It's a public data set, government data set, and it's fairly large. It's much larger than the data sets we've been using. And you'll see some interesting things. It's about traffic stops, and you can look across at most variables. You can kind of figure out what they mean, right? Fairly straightforward. If you would like more information, you can type traffic violations, and over to the right, you see that it opens up help file. You can see there's about 1.2 million rows, so that's why it took a while to load. So pretty interesting data set to look at. To start off with, I have some questions here that I've come up with about this data set that seem interesting to me. And one of the best ways to come up with those questions, if you just have a data set and you don't really have any interest or questions, to start looking at the variables. Things will start coming to you. You'll think, I wonder if, right? So here are some of those questions. How many traffic tickets were issued each year? Have the number of tickets remained constant across the 3 years? Are there certain times of the day that traffic tickets are likely to happen? Are there certain times of the week that traffic tickets are likely to happen? So the variables we're dealing with, you have to kind of parse out what is it we're dealing with. Number of tickets, right? Seems to be something we're looking at. And then predictors of those are hour of the day, weekday, year, things like that. So it's useful if you think about the variables that you are interested in, right? So here I have written out some of the pseudocode for cleaning this. And one of the things I noticed right off the bat when I viewed the traffic violations data set, one of the first things I notice here is that this date is in character, the date of the stop. And so I need to convert it to an actual real date time, right? I need to then pull out the year from that for my question, also the day of the week, and then the hour of the day. And the LuberDate package really makes this quite nice, okay? Let's begin actually coding this up a little bit. Let's start out with I'm typing out the days of the week here, so I need to be able to keep track of these and order them as a factor, right? And then the next thing that I want to do is to start cleaning it up. So I'm going to add some new columns. That means I'm going to be using a mutate, right? And one of the first things I know I need to do is to fix that date of the stop, right? So how do we do that? Well, to do that, the LuberDate package has some nice functions. So they have functions in there that call out the way that the date is set up. So this is not actually a date time, I guess it's a date. And so you don't have to worry about the actual separators in between. You have to tell it what comes first, then next. And when I say what, you have month, day of the month, and you have year. And those can be mixed around in any way, shape, or form. You just got to tell it what comes first. So the LuberDate function is, well, month comes first, then day, then year. And that's a function, so it's pretty nice. And then you just pass in there the variable name. And I can grab that up above. Notice that I'm using tick marks around the variable name. And the reason for this is because these names have spaces in them. And spaces aren't necessarily valid R names, right? So you have to make them valid, and to make them valid, use ticks. And we could actually do some cleaning and clean these column names, but I think it's important to also understand and work with column names that have issues with them, like spaces, for instance. So I'm actually going to go ahead and do something right now. I'm just going to take the first 100 rows, because this is a million rows. We don't want to work with that whole data set. We'll test it out on like 100 first before we start cleaning and do it to all of it. So I just threw in there a command called slice, and then I say grab 1 through 100. That means just grab the first 100 rows and then go on and mutate it. And we can see now, if we run that clean, we can see, oh, this is actually in real date format now, okay? All right, then the next thing we have to do in our cleaning process is to pull the year out. And we have a nice date of stop that's an actual date, so we can just easily pull the date of the year out. And the way we do that, we'll name it, of course, year equals, and there's a year function, LuberDate, imagine that. And we just have to pass into it the variable, which is date of stop, and it will grab for us the year. And we really don't have to do much with it. Let's actually do a select on that so we can see it. We don't have to really do much to it. It's already in double. If we really wanted to turn it to integer, we can with the as integer, because right now it's a float. And there, now it says an integer. The next thing it wants us to do, or we need to do in our thinking process, is to extract the day of the week, right? So we can get the day of the week pretty easily with base R. So we'll call it day of week. And there's a base R function called weekdays. You just rep day of stop around that. It's going to give us almost what we want, but not quite. Let's do a select on that as well. We'll get year. Actually, let's do date of stop, year, and day of week. Let's go ahead and look at it. And the problem is right now it's currently a character, so it will order, if we plot this for instance, it will order it alphabetically, and that's not what we want. So we need to turn this into a factor and order it. So we just wrap it with factor, pass it in the levels we want, and we have those up above, WD. You see that's the, didn't run it yet, there we go, I assigned it to WD, and that gives us the proper order that we want. Now if we go ahead and run that to the console, you'll see it's a factor and it's ordered the way we want it to. The last thing it wants us to do is to extract the hour of the day, right? And if we go back to our data set, we see that there is a time of stop. And we don't want the entire time, we just want to grab the hour, right? So we can call that something like hour of day. And there's a nice function in lubricate. And I'm just going to chain this. I could wrap it around like we have been, but I want to show you that you can chain inside of functions as well. And we're going to chain along the way to hour. And we're going to convert that to as integer. Right? And let's go ahead and select that as well. We can view it. Now let's look at it. And we can see now that there is hour of the day there. It seems a little suspicious that there's all zeros there. And oh, we go down here and you can see right away, date of stop, it should have been time of stop. So look for those things that, hey, this doesn't quite add up, right? Now let's look at it and see if it looks better. There, now that looks quite a bit better. Okay, so we've got our data cleaned and we've pulled out what we want. We can now remove some of the things that we put in there, like selecting only those columns. We can get rid of that slice 100 because we want all of the columns, or all of the rows, that is. And we can go ahead and run that. That may take some time because this is a fairly large data set. And it's done. Now I might want to just look at the those particular columns, which we can do a select statement on. Grab just those columns. And this allows us to see things a little easier than if we have a really wide data set, right? There is no year of stop. Where is that? Should just be year, I guess, not year of stop. There we go. So now we can move into some of our questions. So it asks how many traffic tickets were issued each year. Actually, I decided, just to be consistent with what I had been typing, like day of week, let's do year of stop while we're at it, just to be consistent with things. All right, now let's move on. How many traffic tickets were issued in a year? And we could make a visualization for doing this, but there's really no need. So basically, we need our data set. Let's actually cut out some of this white space in between. We need our clean data set, right? And this is just a matter of counting by year, right? I guess we called it year of stop now. And we can see how many traffic tickets were issued each year in this particular town. And if you don't know, it's Montgomery County traffic violations, that is. So not for a town, I guess for a whole county. So we can see they're actually going down over time, the number of traffic tickets. Okay. Next question is, have the number of tickets remained constant across the 3 years? Which to some extent we answered that question, I guess. The next question we're looking at is, are there certain days of the week that traffic tickets are more likely to happen? So kind of have a guess with that. Like, I'm guessing, maybe weekends are more prevalent. I don't know. It seems like if I am getting a traffic ticket, if I have in the past, it's I get it on the way to work, or it would be like on a weekend, typically like a Saturday, Friday night, something like that. So we can use our tools to help us solve this. So we could use summary statements to figure this out. We could use plots to figure this out. So there's a couple different ways we could tackle this. So I'm just going to grab what we have up above here. And it's asking about days of the week, right? So that's what we're going to want to work with. And this is really pretty straightforward to some extent. It's just a count on the day of week. We'll run that. And we can see that indeed there are some days that are more likely to get tickets. So the weekends actually appear to be lower tickets are issued. And we can see that Tuesday through Friday, more tickets are issued. So that's kind of interesting, right? Gobble up a little of this extra white space. Next question asks, are there certain times of the day or days of the week that traffic tickets are likely to happen? So I guess we already answered about days of the week, but it might be interesting, that kind of sparks in your head, is there an interaction between days of the week and hours of the day? So let's first investigate hours of the day, right? You can see that it's very similar to what we've been doing. And if we want a little more real estate, we can print n equals inf And we're dealing with 24 different values, right? So it's kind of hard to see things at this point. So it's at this point we probably want to actually make a plot, right? So we can ggplot it up, and we're looking at hour of day, I guess. And we know that for this could be useful for a bar plot. And there's going to be an error. Not an error, but it's not going to turn out the way we want. And the reason is, we look at this, and it's kind of hard to figure out scale-wise what's going on here. So you kind of can, you have 0, 5, hour 10. We actually want to see every single hour. And what's happening is, this is treating hour of the day as numeric, as a number, and so it's giving pretty scales, right? So a couple of different ways we can handle this. One of the easiest ways is to turn hour of the day into a factor, right? So if you want to turn it into a factor, that's mutate. And you just say for levels equals 0 through 23, right? Pass that along. Now you start to get what you would expect to see, right? And we can see that towards the hour 21, 22, 23, that's 10, 11, 9, 10, 11 o'clock, we have a lot more traffic citations being issued. So that's kind of interesting. And you might be wondering, well, does that hold true across different days of the week? So here we're now looking at a intersection between those two variables. There's a couple ways we can handle this. I just grabbed the exact same code, and we could fill the bar by day of the week. But we're going to find that that's kind of difficult to work with. What do we call it? Day of week? What was it called in our data set? Day of week. And this definitely has some value, but because so much is going on, it's kind of difficult to compare values. You know, they don't have a common 0 point or whatever. So in this case, it may be more valuable to break it out into like a facet, right? Also keep in mind, I showed this with geom bar, but we could have shown it with like geom line as well. To show it with geom line, though, we'd have to actually do the computation ourselves, where we compute how many traffic stops are happening at each hour of the day. So all we got to do is just do count hour of day. In a sense, this is conceptually easier to work with, so we can actually see in the console what's going on here. And then we can pass it hour of the day, and we can say that our y is n. Now we can do geom line. We can throw points on there as well if we want. We will have to do group equals 1, because it does require a grouping variable for geom line. Now it connects them together. If we want to things that'll be a little thicker, we can do that. Size equals 1. Do points a little bigger. We could change coloring if we wanted. But in a sense, you can see it, the relationship a little different than when we use bars. You see it as more a continuation of time when a line is connecting it. And it kind of strips away a lot of the ink that's not really necessary to show the relationship, right? So I'm just going to grab that same exact code, and I'm going to bring that down. And this time I'm going to color line. We'll do group equals day of the week. And we'll do color equals day of the week. Need to compute that as well, huh? So we throw that in our account, and I want to show you what that looks like. And you can see the error message is quite helpful. Obviously, at that point, there wasn't a day of the week variable, but now I've computed within day of week and hour of day the number of traffic stops. And now we can see some interesting things. Probably going to back off on the size a little bit here. Maybe make it a little bit bigger. And we can see that for hard to tell with the colors, but we can see it is indeed Sunday and Saturday. There's a bit of a different pattern here. It looks like that from about the hours of 6 o'clock in the morning up until about military time. What is that, about 8 o'clock at night? There's, on the Saturday and Sunday, there are far fewer traffic stops. But what we see start happening after about midnight, those days actually start picking up and actually become some of the highest days. You can see maybe somewhere for Friday as well. So right now I'm thinking, is there something different on weekends? Is there a different pattern? So you can see a new question is coming to mind, right, in this exploratory data analysis. So starting to see some interesting pattern, and it makes me want to push on a little further. I think I'm going to get rid of those points because it's becoming a bit too busy, right? And I think I want to understand things by weekend. So what I need to do is, in this data set here, I need to get a variable that says if something's a weekend. And to some extent, it depends on what your definition of weekend is. So I'm going to give you my definition, or maybe in the context of policing. Feels like a weekend is Friday, Saturday, or Sunday, right? Or it's part of the weekend. Friday's part of the weekend, right? So we can make a weekend variable. And how would we get that? Well, we want to find day of the week. And we want to know if it's in Friday, Saturday, or Sunday. Right? How would we do that? If you recall back, you can use %in to do that. Don't use double equals. And the code's telling me something's not right by the coloring. It's a nice thing about RStudio, and it was a missing quote, right? So now I can have a weekend variable. It's logical in my data set, and it tells me if it's on the weekend or not. So we're going to go ahead and now add this into the mix, and we're going to say inside of GM line and aesthetic, I want the line type colored by weekend. Not colored, I mean shown by weekend. I'm going to pull that back. I think I might make it a little thicker, the lines. And these are constant, so it's not inside of AES. Go with 1. And now it's a little easier to see those weekend patterns. And you can see that for the most part, Friday is identical to the other weekdays from about 6 o'clock in the morning until you start getting past midnight. So Friday's just like any other day. It becomes a weekend after midnight, right? And we can see that for these weekends, that from the hours from midnight, 12 o'clock, to about 5 o'clock in the morning, we see far more traffic citations. And for Saturday and Sunday, we see far fewer traffic citations during the actual daytime hours. So what's going on here? Could be that there are less police presence on the, these are just hypotheses. Could be that there's less police presence on the weekends during the daytime hours, and then there's maybe more police presence in the nighttime hours, maybe looking for people who are driving while intoxicated, things like this, and they happen to, because there are more police during those times and less during the day, they tend to also have more traffic stops. So this is a hypothesis, I don't know. We could keep pushing on this, maybe go get more data, maybe talk to experts, but starting to see some pretty interesting things in the data. So this is exploratory data analysis, where you ask questions. As you're moving through, it generates new questions, and you want to look at the data in new and different ways, generate new variables. Like this weekend variable was not part of the original question. So I do want to give a caveat, though, with exploratory data analysis, and you've got to be careful of the questions you ask and make sure that your data can answer those questions, or be careful of the assumptions you're making. So for instance, we have the following questions. Given this data set, what's wrong with the following question in EDA? I wonder which cars are more likely to get a ticket. And so we take traffic violations. We, for instance, find the color of the car and arrange descending on n, right? We say, oh, black cars, silver and white cars. I wouldn't buy those cars. You're much more likely to get a ticket if you have those. And this assumes some causality. So what could actually be happening here? Well, it could be that people prefer black, silver, and white cars, and there are far more of those than there are gold and tan and blue cars. We don't know. We don't know in the general population how many black, silver, and white cars there are proportionally to everyone else. So we can't say really anything about the likeliness of getting pulled over based on the color of your car, because we don't know if these proportions here, these numbers here, match what we see in a population. So we could, for instance, that would be interesting, but we just don't have the data to do it. So we could do a mutate here. We could say n, or prop equals n divided by the sum of n, and that'll give us a proportion, right? And then if we knew the general distribution, or the distribution of car colors in the general population in Montgomery County, then we might be able to start saying, hey, you know, we know that there are, like, I don't know, let's make up a number, 5% of all the cars are black, but we see that there are 20% of the cars being pulled over are black. Well, then we might be able to say, oh yeah, black cars indeed are more likely to be pulled over. Or let's say silver cars here. Well, let's say that we knew from Montgomery County that they make up 60% of all the cars in Montgomery County, but only 19% of the traffic stops. Well, we can say that disproportionately silver cars are pulled over far less than we would expect to see based on their population. So you have to be careful about what questions you ask and the data that you have to be able to actually answer those questions. Now it's your turn. We have several pretty interesting data sets. We have one New York flights, or flights from the data set NYC Flights 13. We have the Diamonds data set from ggplot2. We have traffic violations here. We have the Carnegie data set for higher ed from the example data package. So go ahead, ask. You can start with just one question. Look at the variables, ask one question. Start trying to answer that question. See if you come up with more questions. Try to answer those questions, and just keep working through this iterative process of coming up with questions, answering them, refining your questions, and just exploring that data set and understanding it better.